Hey guys, so we're at lesson 2, and I'm not sure when you're doing these, but it could possibly be Wednesday, April 15th. So I don't know. It could be a couple days after that, but we'll see. So lesson 2, we're going to continue with what we started with lesson 1 with patterns, but today we're going to look at patterns when they're inside of word problems or they're inside of a data table or a pattern table. Also can be called a function table too. I'm probably not going to call it a function table very much. I'll just call it a pattern table to keep it simple. But we're going to get started with word problems first. Okay, so go ahead and read this word problem along with me. While sorting some buttons, Tamara put 8 buttons in the first box, 10 buttons in the second box, 12 buttons in the third box, and 14 buttons in the fourth box. If this pattern continues, how many buttons will Tamara put in the fifth box? So the first thing we want to think about is reading that carefully, okay? And then looking at the order that things were happening and writing out that pattern. So it looks like a numerical pattern. So it was 8, then 10, 12, 14, and then here's the really important thing. We have to double check our question to make sure what it's actually asking. So it says, if it continues, how many buttons will she put in the fifth box? We have to go back here and count and say, oh, 1, 2, 3, 4. So it is the very next number. So now we have to go and analyze this pattern and figure out what's happening. So from 8 to 10, that's plus 2. 10 to 12, that's plus 2. 12 to 14, that's plus 2. So we're going to do plus 2 to get our final answer. So 16. So there will be 16 buttons in the fifth box. Okay, so let's look at another word problem here. Just a little practice here for today. So Robert has a garden and likes to put flowers from his garden into pretty vases. Robert put 2 flowers in the first vase, 4 flowers in the second, 8 flowers in the third, 16 flowers in the fourth, and 32 flowers in the fifth vase. If this pattern continues, how many flowers will Robert put in the 7th vase? So when we look at this, it says 7th vase. So we need to count 1, 2, 3, 4, 5. So we don't want the next one, that would be 6th. We want the one after that. So we want the 7th vase. So the first thing we have to do here is figure out what our pattern is. And then, this is a little bit more complicated, we're going to have to do a little math to figure out, and calculators are okay here if you want to figure out what our 7th one would be. So when I jump from 2 to 4, well, that's getting bigger, so I'm either adding or I'm multiplying. So I could do 2 plus 2 or 2 times 2. So we're going to do 2 plus 2. Okay, so 2 plus 2 is 4. 4 plus 2, not 8. Okay, rewind. Okay, so 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2... yes, it is 32. I'm not playing a trick on you. Yes, it is. So it looks like it's times 2. So we're going to have to do times 2. So 32 times 2 is 64. And then 64 times 2 is, sorry about that, 128. So the final answer here is in the 7th vase, there's going to be 128 flowers. Okay, so that's what patterns look like with word problems. And the biggest thing is to make sure that you read the question carefully and you're actually answering what the question is asking. Okay, so let's go and look at some pattern tables here. Okay, so we have Jack and we have Javier. Jack and Javier are playing a math game. Jack started by modeling a number with place value blocks. Then Javier changed it. The table shows the numbers that Jack modeled, so that is our top line here, and also the numbers that Javier changed them into. So every time Jack did something, Javier changed it. We need to figure out what the rule is here. So Jack is being represented by one of those algebraic letters, which we call a variable. So his variable is J. So this whole line stands for J. Okay, so whatever Jack does, he's J. Okay, so Jack had 17, and then Javier changed it to 13. Jack had 20, Javier changed it to 16, and it continues down through here. So we have to look at this. Is there a consistent pattern? So when it was 17, to get to 13, he took 4 away. So let's check here. 20 to 16, oh, that is minus 4 also. 25 to 21, minus 4. And then the pattern continues. So when we talk about this, we talk about it as a rule. So our rule is that whatever Jack has, Javier is taking 4 away. So when we write that as a rule, we're going to use that variable of J. So whatever J was, Javier ends up being 4 less. So Jack minus 4 would equal out to be Javier, but we're just going to write this as a regular expression. Okay, so let's look at another example. Okay, so I have Jack and Javier again, but different things happening. Okay, so we need to figure out what's the rule for this table. And we're going to write it like an algebraic expression with a variable and a number and an operation. So we're going from 17 to 24, 20 to 27, 25 to 32, 32 to 39. So I'm going to pause for a second and let you think about it. Okay, guys, what do you think? What's happening? So from Jack to Javier, it's getting bigger. And that's one of the kind of the rules of these pattern tables. You always, when they're set up in this horizontal fashion, you always go from top to bottom. So from Jack to Javier, what's happening? Oh, I know you know it. It's getting bigger each time by 7 consistently the entire way down through here. So our expression would be, we need a variable, we need a math operation, add, subtract, multiply, divide, and we need a number. So we already know it's plus 7. So in order to make that expression, it would be J for Jack plus 7. Okay, let's look at another example. We have Sheena and Julie now. They're playing a math game. Sheena starts with something and then Julie's changing it. I just summarized basically what that said down there. So we're going to have to figure out a rule. Okay, so when I look at Sheena, she's at 6 and then it's jumping to 18. Okay, so I have two options. It's getting from smaller to bigger, so it could be adding, it could be multiplying. If I add, it would be plus 12. Hold on, lost my pen here. So if I add, it would be plus 12. If I multiply, it would be times 3 because 6 times 3 is 18. So let's just double check and see which one of those works. So when I go to the next term, 12 plus 12, oh, it's not 36. So let's check our other one. 12 times 3, yes, that is 36. So let's go through and check. 14 plus 12, oh, it's not 42. So we're going to say, that plus 12, not really working out for us. So we're going to keep trying this 3. Hey, if you don't know what 14 times 3 is, double check it. But 14 times 3 is 42. Okay? And then 20 times 3 is 60. So the rule coming from top to bottom is times 3, but we want to write this out as an expression. So we need to assign a variable to Sheena, okay? Because we're going to go from top down. We always go from top down. So Sheena, let's just simply call her S times 3. So Sheena times 3 gives us the other person. If we wanted to write this, if we wanted to write this as an equation, it would be Sheena times 3 equals J for Julie. Okay, but we're focusing more on expressions. Those, just remember those expressions are when we don't have an equal sign and we don't have an answer going with it. So it's just an expression, no equation. Okay, so let's look at one more. Okay, so this one looks a little different. We don't have names here. We just have R. And the R row says 19, 24, 32, 37. Okay, and then the bottom row we have a blank. Okay, and we need to figure out a rule here. So right here in this first spot, we're going to write a rule. Okay, so R something, and then eventually we're going to use that rule to figure out that blank space there. So we need to look and figure out what's happening from top to bottom. So from 19 to 7, it could be division, it could be subtraction. I'm pretty sure it's not going to be division because 19 is a prime number, which means it has no factors other than itself and 1, which means there's no way to get 7. So I have to think about this as being subtraction. So 19 minus something is 7. So I can flip that and say 19 minus 7 to figure out the other number. Well, 19 minus 7 is 12, so 19 minus 12 is 7. So let's double check that. Does that work? Is 24 minus 12 12? Yep. Is 32 minus 12 20? Yep. So my rule would be whatever's on top or R minus 12. So now we need to use that rule in order to fill out this last number. So what is 37 minus 12? So I'm going to pause here, give you a chance. You can hit pause too and figure out what that's going to be and then check back. Okay, so 37 minus 12 is 25. So our rule there is R minus 12, and our missing value or our missing term is 25. Okay, we're going to look at another one of these. This time I have K, okay? And K stands for 14, 21, 49, 63. And let's figure out what's happening to K in order to get the bottom number. So we're going to put our rule in here, and we're going to eventually fill that in. Okay, so to get from 14 to 2 and 23 to 21 to 3. Well, 14 to 2, that's getting smaller, so that's either subtraction or division. Well, if I subtract, it would be minus 12. So I'm going to look over here. 21 minus 12, not 3. Okay, so I'm going to go back and look at division. 14 divided by, 7. So I'm going to say divided by 7. There's my fancy division sign for algebra. So 14 divided by 7 is 2. Let's check. Is 21 divided by 7 3? Yep, 3 times 7 is 21. Good. 63 divided by 7 is 9. Yes, it is. So then we have to figure out what this missing one is here. 49 divided by 7. Everyone think about your 7s. Hit pause if you need a little longer to figure it out. 49 divided by 7 is 7. So one more thing we have to do is fill in our rule. Now, we could write this two ways. We could use our traditional division sign, or we can use our fancy algebra sign, or we could even write it like a fraction, if you remember that part. Okay, so it's K divided by 7, K divided by 7, or K divided by 7. Writing it in any of those ways is totally fine. Okay, hey, that is the end of my lesson. I don't think I want to, let me quick browse through the rest of these, see if there's any more I want to do, but I think that was probably a pretty good intro for you guys. Nope, I think we're good, guys. So once you're finished with this, I have an activity for you to do that I'll put a link on there. And if you have any questions, you know I'm around for office hours at any time. Hope you have a great day.